Okay, class, number 3. It says, now investigate some general properties of vector addition. Begin by sketching any two vectors A and B as arrows that have different directions but no points in common. So what I'm going to do is I'm just going to draw vector A right here. We'll call that A. Okay, now vector B. If I add these two together, in other words, if there was a way for me to grab that vector, and slide it here, I now would have the resultant vector, term that you need to know, resultant vector A plus B. But what about B plus A? What if I take vector B and I add that to vector A? Do I get the same vector? Well, let's take and move all of this out of the way. Let's move vector B down here and move vector A over there. Now, starting in the same spot, approximately right there, if I take vector B and then add to that vector A, do I still get the same resultant? And the answer is yes. Therefore, A plus B, vector A plus vector B, is the same as vector B plus vector A. So one more real quick demonstration, and this actually gets to the point of the parallelogram method. If I take vector A, this is going to be a different vector. Let's say, that's due east. Let's say vector A goes this direction, and I add to it vector B. Is A plus B still equal to B plus A? Well, I'm going to try to duplicate I'm going to try to redraw now vector B, start with B, right there, and I'm going to add to that vector A, right there, and that gives me the same resultant. We often call that resultant as vector R. So it really doesn't matter where you go in the coordinate plane. Vector A plus vector B is going to give you the same resultant as vector B plus vector A. And it's going to form, when you put those two vector addition problems together, a parallelogram.